Okay, so now part 3. So we will start with the size function for the list, and we'll test it out using this example in the application. So again, if we go to the header file, this time we will focus on this function, size. And we would like to test it out based on the fact in the application that we've inserted at least one node. Let's see if we get that 1 back as an integer. As stated here, the return type for the size function is an integer. So now we need to create this function in the implementation file under accessors for this class client list. So this will have an int client list, and this time we will pull out size. Surprisingly, the display now is showing what we need to have here in terms of function choices. So client list asterisk head, okay, and it would be a const, so it's going to be very similar in construct as the is empty, except this time we're going to have to set up a counter and step through the list. Okay, so we need some sort of a counter. So maybe int count equals 0. So set it to 0, reset it, make sure that you're starting at a certain point. If the head is null, think about it. The list is empty. Might as well return the count. So you could clearly state that if head is equal null, go ahead and return count. If not, then that would be an else statement here. And whatever comes out of the else statement, we will return the count at the end of the function or the procedure. So what are the things we need to do? We need to step through the list. Okay. So to step through the list, I'm probably going to need a temporary pointer. I like to call it position. And at that temporary pointer, I will initialize it to head first. That means make it point to whatever head is pointing at. And then move the position pointer until it's equal to null, and then get out of that loop. While it's moving in that loop, go ahead and increment the pointer. And obviously we need to have a loop control to make this happen. So client list asterisk. We're going to call this one position, and we're automatically going to make it equal to head. Oops. There you go. Okay. So this is the only time we need to really bother about utilizing a temporary pointer. It's in the else statement of this if statement, because now we need to use it in this while loop. While position is not equal to null. Now in the body of the loop, so let me put 2 curly braces. We're going to do a couple things. One, if you're stepping through the loop, go ahead and increment the counter, count plus plus. But how are you going to move? How do you move the position pointer across the list? Well, you're going to use the next pointer for that purpose. So you're going to make the position pointer equals to whatever position pointer next is pointing at. And that's how eventually the position being equal null will be true, right? And which means position not null is false, and it will kick you out of the while loop. Okay, so we could use this to verify quickly if we get a count how many records are stored in the linked list. First, let's save this. Let's rebuild all just to make sure I didn't make any. Okay, so I've got something going on here. I did card count. Position. Position. Here you go. Good. So what happens when you build code from scratch a little bit? So let me see here again. Perfect. So now let's go ahead and test it out. Test out this function. So maybe what would happen is if you have an else, maybe it's a good idea to go ahead and display cout. There are, and then this is based on CList, CList up, and size, and do pass CList to it, records, or nodes, if you will. I'll call it records since they are clients in this list. Do a /n here, semicolon, close the curly brace. So what I'm going to do is reuse the same statement for the else right here. Copy. And I'm just going to paste over this, so right over it. There you go. And then go ahead and test this and see if we do get the number of, so obviously this will say empty the first time around until you push data into the list. So we should get a 1 back. So let's go ahead, compile and run. And sure enough, there are 1 records in this list. Now, can we prove that we can actually enter more than 1 record? Can we enter more than 1 record? Yeah. I could reuse, right here, before I do this, I could reuse CL and enter a new record. So I could do something like this. CL equals new client. So what I'm doing now is I'm dynamically reallocated CL, and what I'm going to put in is a new node, what will be a new node in the list. So I need a new object, right? So I have Henry Ford. Let's put somebody famous here. Jane Fonda. There you go. And what would be a good ID? Yeah, I know what you're thinking. Non-political, movie style. I can't come up with one. I'm just going to call it T99X45. Okay. Now, nothing happened until I do what? Until I insert this into a list, right? So I'm going to have to insert this into a list. So CL list. And the only insertion function that I have is push front at this stage. So the reason I'm using this, and the reason I'm doing this, is to prove that, first, the list is not going to be empty, and that it is tracking how many nodes are being stored in the list. So that's all I'm doing right now. So let's see if this will work. So let's go ahead and compile and run. And sure enough, the list was empty initially before I actually put any data. Now, there is at least 1 node in the list. In our case, there are 2. There are 2 records in the list right there. Okay, so it did update based on the fact that I pushed 2 items into the list at the end of it, at the tail end. Let's see. That's where that exclamation point was hiding right here. So I was wondering why the exclamation point was showing up on the output. That's what it was. So let me just rerun this. Compile and run. Okay, much better. Still, the results are the same. I was wondering if I could make the font any bigger, but that's about all it will do. For now, I might have to do some drastic changes over here. Okay, so we've got the function size working. We've implemented the code for it. Okay. I would like to insert back now. So I'm going to go back to my mutators. So instead of pushing front, I am going to push back. Okay, so that would be our next procedure to design. And let's go ahead. Oh, I did say we would like to see the view all first. Yeah, I'd rather do that right now and see if we can actually see the data. So forgive me. Let me start with that first. So let me go over here. Again, you realize I'm writing code from scratch here. This is non-scripted, okay? This is where you might see me going back and forth in terms of as I'm writing this code, and it's as if in my classroom I'm doing live coding here. I would like to do a view all, or a view and view list. That's what I called it, I believe, right? So it's called view list. Right now, I might as well go ahead and see what's in it, okay? This way, so I don't write too much code and then not realize that, yeah, it's counting the number of records, but it may not be showing me the records. I want to prove that it actually can do that. So under accessors, I will have void client list, and this would be view list. So let me just pick view list if I can see it here. Let me just type a V, and it should show up. Oops. There you go, view list. And again, the nice thing about this is you can predict pretty much what I'm going to be doing here. Client list asterisk. And that would be the head of the list. Okay? All right, it's going to be very similar to the previous set of examples we did for the integer list. So you need a pointer that points to the head of the list, not just head itself. Why? Because that's the one I'm going to move across. And I'm going to dereference it based on its payload to see what kind of data it's looking at. Now, this one is going to be interesting because it will be a multi-step process since we now have an object instead of an integer as payload. So this one will be a little challenging. So just pay attention. List asterisk, and that would be position equal head. All right, so we are setting up our new pointer here, local pointer variable called position. Okay. By the way, we could make everything based on the fact if it's empty or not. Right? So we could condense the empty or not empty right here, and then I'll delete everything else that is in the application. Okay, so I could do something like this. If is empty, what? Pass head to it. Then cout, empty list. And we'll just do that here. Else, we're going to do a whole bunch of things. Let me see. I've got an extra quote there. That's why it did that. Else, we're going to do. We're going to do a whole bunch of things. Maybe, maybe not. Or we could do a size right now. Cout. So I'm going to try to condense it all in here so we don't have to do what I did in the application every time here. So we're gonna have it whenever we try to view all, have it do this for us. We've seen in the application. We could do something like this. There are, and this time call the function size and pass head to it. And we could say records in the list, in this list. /n. Do that. And we're done with that if else statement. Now we need to step through the structure and print its content. So this is the fun part, actually. Make sure that I have everything here. So this is the fun part. While position is not equal to null. Curly brace, close curly brace. Let me just delete a whole bunch of lines here so we can make it a little more efficient. Now, how do you move through this anyway? Right, so how do you move the pointer? So I'm going to make that my last instruction. So that would be positioned. So it's very similar to what we've done before, equal position next. So if you can do this, you pretty much understood how to move through this loop and make sure that you get out of this loop. So while you're doing all of this, what's going to happen in between, maybe this is a good time to go ahead and print what the payload looks like, and then print the actual key that you've assigned, right? So to the key within this class, which is based on the ID or the client ID that's already in the object. Okay, so we could do that as well. So cout. First, we want to show what the payload is. Payload. And what's in this payload? Now, this time it's not an integer. So position, what is the position pointing at? It's pointing at payload. But we have one more thing. This is where it gets interesting. The payload itself has a function to print, right? The payload itself, right, which is the client, has a getInfo method that returns a string, and it will return all of this data for you. Now, if this was an integer, you'll be done, right? So you're just dereferencing the integer value, you get the integer value. This is a whole string concatenated. You're going to use the advantage that the getInfo returns a string. Fantastic. So you're going to go over here and you're going to say one more thing. So if you're not familiar with this kind of code, get familiar with it now. And it will do getInfo right here. Oops. Info right here. And L. The reason is I don't have a /n in that one, so it will take care of that. Can we print the value of the key? Yes. We know that if you've assigned the node or created a new node at the same time, you've created a key. So now I'd like to see if the key indeed is equal to the payload ID or the, so one way to do it is to verify right here. Key equals, and okay, so what do we want? That would be, in this case, position, just dereference the key. There's no need to go any further because that's the one you want from the class list. And L. Now let's go ahead and test this code. So first, let's go ahead and compile all this, rebuild all. Okay, so I made a boo-boo somewhere. Let me see here, client list, view list. Did I miss? It's a const, right? So I forgot to put the keyword const here. All right, so rebuild all. There you go. Perfect. Okay, as I said, live code, it's a lot harder than rehearsed or PowerPoint slides or anything of that nature. So here we go. Now let's see how it works. Okay, so we're going to go over here. I'm going to redo some of this stuff here. So let me just delete all of this stuff. We don't need this. So we push, we create a new client. We push, we create a new client. So what we could do is, so let me just delete here. So we could see what I did is I pushed, created an object, right? Pushed it front, created another one, pushed it front. Prior to that, I'm going to go ahead and try to see if the CL list view all has any information, right? So it's a good start. So CL list, and that would be view list. right? And then you're going to pass CL list to it and see what happens. Then we're going to do the same thing. Okay, so here you could do cout state of the list at start of the application. Okay, so you could do something like this to explain what you're doing, right? And we're going to do cout state of the list after a couple of insertions to the front of the list. Front of the list means the tail. Let me call it to the tail of the list. There won't be any confusion as to relatively where that is. Okay, and put a semicolon here, and then we're going to do a view all. So CL, maybe a couple /n's here just to separate the output here. So CL list, again, view list. Now, this is going to tell us if we have an issue with integrity in terms of memory allocation usage. We know it counts, but we want to make sure that we're actually viewing the data we entered. Let's see how this works. Compile and run. And sure enough, it's working. Right, so let's see what do we have. Yeah, so we have client name Henry Ford, and it's telling us we have 2 records. Okay, the key is this. Then next payload is this, right, with the key of this. This is nice. Okay, all right, so we know it's working. It's displaying the items that we've entered in the application, Henry Ford and Jane Fonda. Okay, so now let's have it insert. And notice the order in inserted, obviously, at the end of the list, right? So at the tail of the list, that is. Jane Fonda is second, right? So I would like to insert an item that would go before Henry Ford. Well, that's what I started doing, and then I backtracked and I said, nope, wait a minute. Let's make sure at least we can display stuff. So let's get back to under mutator now and do a pushback, which will put an item behind the existing head of the list. So at this stage, we're going to do void client list. And this would be a pushback. So pushback is right here. And notice how consistent our code is going to be. Client underscore list, asterisk, and %head, comma, client, asterisk, data. Okay. All right, so I want to keep using the same variable names, keep my code consistent, predictable. Okay? I can go on vacation and hand over my code to someone, and they can continue on with it. So I want to do pushback. And to do pushback, again, just like push front, you need to create the node, first of all, and then we're going to insert it behind. So in our case, we don't need to step through the whole list, just like we did with push front. Why? Because we know exactly where we are. We don't worry about the size of the list to begin with. We just need to be behind the head. However, there's a caveat to that. What if the list was empty? Well, then we're it. So you have to have a condition. If it's null, then the head will be the new node you create. If not, go behind it. Okay, so that's the basic strategy for this one. So first, create the new node based on this data that you're supplying it. So client, remember your nodes are of type client list. And that would be my node equals new client list and supply it with data. That's it. That's pretty much how you create the new node. It's not attached to the list yet. And like I said, this is going to be conditional. What if head is null, which means you had nothing to begin with? Well, that will be your thing. This node will be part of the list. So if head equals null, not a problem. Go ahead and make head now equal my node. That's the easy part. Else, which means now I actually had something. Head was not pointing to null. It was not null, right? So we're going to do a couple things. We're going to have to reassign head to this new node, right? After we insert this node. So we're going to have to make my node next point to head as it is. So my node next, make it point to to head, I'm sorry, right there. Okay. So this new node will be pointing to the head of the list. So the new node will point to the head of the list, of the existing, to be even more precise, list. Okay, next part of the strategy is now reassign my new node as head. So head equals my node. Okay. And this here, make the new node the head of the list. That's the secret sauce for this one. Well, let's see if we can make it work. Let's see if we can test it out real quick and see if it works. So I'm just going to go ahead and save all this. Rebuild all, just to make sure I don't make any mistakes. Everything looks good. Let's go over here, and now we're going to create a new item, right? And we're going to do it right after this, like here, right? So this one, let's do it right here and create a reassign CL equals new client. And let's create a new object or values for the attributes. I like Frank sauce from Upper State New York. They make really good sauce. There you go. And excellent on chicken wings. So I'm going to call it New York sauce 100. There you go. Okay. So now this one, I'm going to push it to the back, which is behind the head. So CL list. Just give me a space here just so for clarity. And then this one would be a push back. Notice how consistent the code becomes. CL list. Okay. Which one? CL again. And notice that's all I need to do. Because after that, we could see what the list is, and will have, and you should have 3 records based on this. But we will see that Frank sauce will be at the beginning of the list. All right, so let's see if that is true. Compile and run. And sure enough, as you could see, Frank sauce is at the beginning of the list. Henry Ford, Jane Fonda. Perfect. Now, what if we want to delete a record? Okay, the deletion is a little more complex, so we're going to leave that for the next part, right? So the next part, we're going to deal with the deletion, and it's going to involve the keys that we've stored in the list as an item, right? So if you look at here, so we have keys, but these keys, we strategically made them equal to, so when we did the insert data, we made them equal to the actual data's return, the string returned by the get ID for that object. Okay, so that will be next. Okay, so thank you and stay tuned for the next part.